Dad, my textbook says electron microscopes can see atoms. How's that even possible?
It all comes down to wavelength, Steve. Regular microscopes use visible light, which is too big to resolve atoms. But electron microscopes use accelerated electrons, and they have wavelengths thousands of times smaller.
So smaller wavelength means better resolution?
Exactly. The de Broglie wavelength of a high-speed electron can be under 0.01 nanometers, which is what allows you to see at atomic scales.
So how do they form an image with electrons?
In a transmission electron microscope, or TEM, a beam of electrons is shot through an ultra-thin specimen. Electrons scatter based on the material's structure, and detectors measure that to form a high-resolution image.
What if the sample is thick?
That's when you use a scanning electron microscope, or SEM. Instead of going through the sample, the electron beam scans across the surface, and sensors collect secondary or backscattered electrons to build a three-dimensional-like image.
No lenses like in normal microscopes?
No glass here! Electron microscopes use electromagnetic lenses. Magnetic fields steer and focus the electron beam instead of bending light.
Why does the sample have to be in a vacuum?
Because electrons would scatter off air molecules. A vacuum ensures a clean path and maintains beam coherence. Plus, most samples are coated in a thin layer of metal to prevent charge buildup.
So it's part quantum, part electromagnetism?
That's right. It's quantum mechanics in a giant steel box. And it's how we image viruses, nanomaterials, and even individual atoms.